Very good morning, students.
Good morning.
Good morning, sir.
Good morning, all of you. So let us start the discussion without wasting any time. Last class, if you remember, we have been discussing about polymers, and we have seen different types of addition polymerization reactions and examples of addition polymers. In the same way, we are going to continue now today with the condensation polymerization and different types of polymers involved in those type of reactions. Condensation polymers are also called as step growth polymers because in every step there was some growth happening in that polymerization reaction. So if you look at the type of condensation polymers, you will be first getting the polyesters. In the polyesters category, you will have glyptol, terylene or dacron, and PHBV. Okay, so these are all polyesters. That means esters are going to be formed. And what type of reaction you can expect whenever ester is going to be formed? An acid and a base, and acid, a carboxylic acid and alcohol. They are going to be reacting to form ester. Same type of reactions as that of esterification. In the esterification, which bond is going to be cleaved in the alcohol?
OH.
In the esterification, we have seen the mechanism many times. Esterification reaction. In the esterification reaction, which bond will be cleaved in the alcohol? In the alcohol, you have the cleavage of OH bond. In the carboxylic acid,
You.
in the carboxylic acid, the CO bond is going to be cleaved. Yes or no? So glyptol, first one. Glyptol is a polymer of ethylene glycol and phthalic acid. This was a phthalic acid. If you look at the phthalic acid, here the CO bond has to be cleaved. In the ethylene glycol, that is alcohol, the OH bond has to be cleaved. Same in the continuation, this OH bond has to be cleaved. This CO bond has to be cleaved. So if I try to write the respective polymer, I have to write the oxygen connected to some other groups because the OH bond is actually cleaved, connected to CH2, oxygen of ethylene glycol, other oxygen. This is connected with the carbon of phthalic acid, C double bond O. This CO bond has been cleaved, and this is connected to the phenyl ring. This is connected to the phenyl ring, and here you have again C double bond O. Again, in that other acid, which bond is actually cleaved? The CO bond, right? Not the OH bond. So this bond again cleaved. So with that, the repetition is going to happen. So this is going to be repeated n times. So that is how we have to write. The oxygen hydrogen bond, that is OH bond in one part of the ethylene glycol. Ethylene glycol is a dihydric alcohol, right? So one of the OH bond has been cleaved and reacted to the C double bond OH. The CO bond in acid has been cleaved. You are generating O C double bond O group. Along with this O C double bond O, in the other terminal, you have again C double bond O. Again, that carbon oxygen bond is going to be cleaved. So this is how you have to repeat. In case if you have an arrow here, that is wrong. Because the OH bond is actually cleaved in the alcohol, not the CO bond. So you have to place the arrows properly. In case you have an arrow in this fashion, like in the C double bond O, here if I keep an arrow, that is also wrong because it indicates the OH bond is cleaved in acid, but in reality the CO bond has been cleaved. Understood how to represent? Okay. Ethylene glycol, whenever react with phthalic acid, same carboxylic acid reacting with the alcohol is going to happen, and this reaction can be slightly faster in the acidic medium, and in that case you will be getting glyptol and CO bond in acid and the OH bond in alcohol. Those has been involved in the cleavage. Let us proceed for the manufacture of paints, lacquers. These are the uses of this particular ethylene glyptol, that is ethylene glycol and phthalic acid polymer. And it is an ester. The esterification happened. The ester is actually formed. That is why it is said to be a polyester. That is why it is called as a polyester. Terylene or dacron. Ethylene glycol, whenever it reacts with the terephthalic acid. Earlier we have phthalic acid, that is 1,2 dicarboxylic benzene dicarboxylic acid. 1,4 benzene dicarboxylic acid is said to be terephthalic acid. Whenever ethylene glycol reacts with terephthalic acid, what happens? Same reaction, same type. OH bond cleaves here, CO bond cleaves here, CO bond and OH bond. You are going to have this type of polymer. OCH2CH2 O C double bond O. Just the group position of the group has been changed, and you have C double bond O. This is repeated n times. Ethylene glycol reacted with terephthalic acid to form the respective terylene or dacron. It is also a polyester. The only difference between the terylene or dacron and the glyptol is in glyptol along with ethylene glycol you have phthalic acid, that is 1,2 benzene dicarboxylic acid, whereas in terylene or dacron along with ethylene glycol you have terephthalic acid which is 1,4 dicarboxylic acid, which is 1,4 dicarboxylic acid. Is that clear, students? Yes, right. Very good. Next, poly beta hydroxybutyrate co beta hydroxyvalerate PHBV. It is a biodegradable polymer because a lot of polymers, whatever you are preparing now, they are not degraded easily in the earth crust. So the degradation process, if it is taking decades and more than that, then obviously that is not so useful, and that is why we are now actually preparing some biodegradable polymers. Biodegradable. Poly beta hydroxybutyrate co beta hydroxyvalerate PHBV. That means if you look carefully, it is butyric acid. In the butyric acid, like if you go with the numbering 1, 2, 3, 4, 4 carbons are there. This is the alpha carbon to which COH is directly connected, then the beta carbon. On the beta position, you have H group. Same with the next molecule, that is valeric acid. 1, 2, 3, 4, 5 carbons are there. And this is alpha carbon, this is beta carbon. On the beta carbon, you have OH group. So poly beta hydroxybutyrate, that means beta hydroxybutyric acid and beta hydroxybutyric acid and beta hydroxyvaleric acid, they are going to be reacting with each other to form the respective ester. How the reaction is going to happen? Same again, that is carboxylic acid and alcohol reaction, esterification. OH bond is going to be cleaved in the alcohol, CO bond is going to be cleaved in the acid. Same here, CO bond is going to be cleaved. Same here, OH bond is going to be cleaved. So you have C double bond of the carboxylic acid connecting with the oxygen, because this OH bond and this CO bond and this OH bond has been cleaved, and you see the loss of H2O. So ultimately we will be generating what? So here also we have seen the loss of H2O. So 2H2O, loss of 2H2O occurred whenever two molecules have been just reacted, and we are getting O, CH3, CH2, C double bond O, CH, CH2, CH3, CH2, C double bond O taken n times. So it is a biodegradable polymer. PHBV is used in specialty packing, orthopedic devices, and in controlled release of drugs. And PHBV undergoes bacterial degradation in the environment. In the environment, it will be degraded easily, and that is why its usage will be slightly more. And obviously, it is a copolymer. All these things like glyptol, terylene or dacron, and PHBV, all these polyesters are copolymers because we are using more than one type of monomer. We are using more than one type of monomer, so they are all called as copolymers. Okay. So look at the example. Which of the following organic compounds polymerizes to give the polyester dacron? Try to answer this.
Option. Third option.
Third option.
Terephthalic acid and ethylene glycol. So option 3. So such type of questions we will be expecting from polymers. Like mostly they'll ask questions regarding the monomers or the questions regarding the type of the structure of the polymer based on the polymeric unit. Okay, be careful with the monomers and the usages and all. Next comes the category polyamides. In the polyamides, you will have nylon 6, nylon 6, nylon to nylon 6 categories. Again, nylon to nylon 6 is a biodegradable polymer. So first of all, what is nylon 6,6? It is obtained by the reaction of hexamethylene diamine and adipic acid. Again, loss of H2 occurred. So loss of simple molecule happening means it's a condensation polymer. And now the reaction is going to happen between the respective carboxylic acid and amine group. So if you think carefully, let us take R and H2. This total group is R, let us say, and R dash C double bond OH. Okay, to understand what is actually happening, Let us take RNH2 and R dash C double bond OH. Like if you remember in the protein also the same type of reaction we have seen. Yes or no? In the amino acid, one amino acid and the other amino acid, they are going to be connecting with each other through peptide linkage. Peptide linkage is an amide linkage. So amide is going to be formed. Actually, the CO bond is going to be cleaved here and NH bond will be cleaved. The mechanistic approach is simple. Lone pair of electrons and nitrogen, they attack the carbon. As soon as they attack, they form R connected to nitrogen, two NH bonds. Nitrogen has a positive charge and it is connected to carbon. The pi electron is moved away. So carbon connected to O minus and carbon also connected with the OH group and carbon also connected with R dash. Now what happens? Lone pair of electron present on oxygen, they will try to pick up the proton. NH electron density will be given to nitrogen. It forms R, NH, nitrogen regain the lone pair and a CO minus. Carbon connected to oxygen, oxygen has only one lone pair, two OH bonds and a positive charge. It is connected to R dash. Now ultimately what happens? Negative charge on oxygen comes into the loss of water can be seen. Loss of water can be seen. You have R, NH, C double bond to R dash. So ultimately what happens, students? The NH bond in amine and the CO bond in acid has been cleaved. So I can cleave this bond. One NH bond I can cleave. One NH bond I can cleave. And here also CO bond I can cleave. So NH will be repeated CH2, NH, C double bond O, CH2 taken 4, C double bond O taken N. But here we have hexamethylene diamine, so we have CH2 taken 6 times here. Hexamethylene diamine, whenever it reacts with adipic acid, it undergoes the formation of respective amide system. So it is called as a polyamide. It is called as a polyamide. Hexamethylene diamine reacts with adipic acid to form nylon 6,6. And these nylon 6,6, they are useful. This polymer is useful in making sheets, bristles for brushes, and in textile industry, like fibers, right? These are all the fibers, so they are going to be useful in the textile industry as well. So wherever the polyamide you can see, there you can simply undergo the cleavage of CO bond in the respective carboxylic acid and NH bond in the respective amine and link them NHC double bond O, the amide system is going to be formed. Nylon 6, it is actually obtained by the heating of caprolactam in the presence of water. So caprolactam, whenever it is heated to 533 to 543 Kelvin in the presence of water, it forms nylon 6. How this reaction is going to happen? It will form first amino caproic acid. How this amino caproic acid is going to be formed? If you try to understand the mechanistic approach, students, the caprolactam is now going to be attacked by water or not? Let us take this caprolactam and let us look at the attack of caprolactam with water. Water is actually a nucleophile. It tries to attack the electrophilic carbon, and this carbon is going to be electrophilic. Obviously, we know lone pair of electrons and nitrogen, they were in great resonance with the C double bond O. So the electrophilicity of this carbon is less. So to increase this reaction, we maintain the temperature high, or we have to increase the electrophilicity by taking some acidic medium. So this water attacked the electrophilic carbon, C double bond of pi electron and moved away. So we have NH group connected to CO minus, and you have oxygen, two OH bonds and a positive charge on oxygen, and this was involved in the linkage. Now what happens? Negative charge on, like if you took at nitrogen possessing lone pair of electron, that lone pair of electron present on nitrogen, that will try to pick up the proton from the OH2 plus, because positively charged oxygen is not so stable. So you will form NH. This group is as it is. Okay, that group is as it is. NH, nitrogen used its lone pair. So two NH bonds are going to be formed now. Two NH bonds. Nitrogen will have a positive charge. It will also connect with carbon, CO minus. Carbon is now connected with the OH as well, and oxygen regains the lone pair. So only one OH bond. One, two, three, four, five. Okay. Right. And now what happens? Negative charge on oxygen comes into the carbon nitrogen electron density that will be given to nitrogen to regain the positive charge. You will be having NH2, CH2, 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 C double bond OH. So this is nothing but your respect to amino caproic acid. Whenever you heat caprolactam in the presence of water, you will generate amino caproic acid. This amino caproic acid will be forming respect to nylon 6, and how it is going to be formed? The NH bond, like if you do the polymerization, what will happen, students? Which bond is going to be cleaved in the acid?
CO bond.
CO bond. And in the amine, which bond is going to be cleaved? NH bond. So NH linkage is there. CH2 taken 5 times. C double bond O and CO bond is cleaved. So this is going to be repeated n times. That is nothing but your nylon 6. Caprolactam, whenever it is heated with water, it forms respect to amino caproic acid. That amino caproic acid will be just polymerized to form the nylon 6. Right? Same linkage. It is used in the manufacture of tire cords, fabrics, and ropes. And it was a homopolymer, not like the previously discussed polymers. Because why it is called as a homopolymer? Because only one type of monomer is there. Only a single monomer is there. That is why it is called as a homopolymer, not a copolymer. Right? Nylon 2, nylon 6. It is also biodegradable. Next category. It's a polyamide. Glycine will be reacting with the amino caproic acid. NH2, CH2, C double bond O, OH. What is glycine? Glycine is the optically inactive amino acid. The optically inactive amino acid, that is glycine, will be reacting with amino caproic acid. Same reaction again. Acid, carboxylic acid will be reacting with the respective amine. Which bond will be cleaved? The CO bond and the NH bond here. You can write 2 NH and one of the NH bond is going to be broken. In acid you have CO bond, here you have NH bond, they are going to be cleaved. And you will generate NHCH2 C double bond O. NHCH2 taken 5 C double bond O. This is going to be repeated n times. This is nothing but your respective polymer, which is nylon to nylon 6. It is a biodegradable polymer. And it is an example of copolymer because we have taken two monomeric units. Glycine and amino caproic acid, two monomers are there. So this will be respective example of a copolymer, not a homopolymer. Is that clear, students?
Yes, sir.
Yes. Yes.
Yes, right. Which of the following polymers is prepared by condensation polymerization? Try to answer this. Styrene, nylon 6,6, Teflon and rubber.
Nylon 6.
Nylon 6,6. Very good. Nylon is an example of
Polyamide.
nylon 6,6, nylon 6, nylon 2, nylon 6. They are all polyamides. Caprolactam is used for the manufacture of
Nylon 6.
Nylon 6.
nylon 6, not nylon 6,6. Okay. Then comes the next category of polymers, that is phenol formaldehyde polymer, Novolac or Bakelite. If you take phenol and if you try to react with the formaldehyde in the acidic or basic medium, what is going to happen is phenol is an electron donating group or electron withdrawing group. Phenol is an electron donating group. Yes or no? Phenol, since it's an electron donating, like OH group in the phenol is an electron donating group, that will be actually increasing the electron in state ortho and para positions. It will be increasing the electron in state ortho as well as at para positions. So we can say lone pair of electron present on nitrogen, they will ultimately increase the electron in state ortho and para positions. So the electrophile is going to be attacking at ortho and para positions. Out of ortho and para, ortho is going to be major product. And the ortho-hydroxymethylphenol, whatever we have, that ortho-hydroxymethylphenol will be again polymerized to produce a Novolac, which is a linear polymer. Understand this point carefully. We have phenol and HCHO. Phenol be reacting with the HCHO to form the respective orthohydroxymethylphenol, para-hydroxymethylphenol, and disubstituted and trisubstituted products. But orthohydroxymethylphenol, whenever it polymerized, you will get a linear polymer, which is also called as novolac. If the novolac has been cross-linked, then you will get a cross-linked polymer, which is also called as bakelite. So let us look at the mechanistic approach and how the reaction is going to happen. So phenol, if you try to write the resonating structure, the lone pair of electrons and oxygen, they comes into the C double bond C pi electron and C moves away. You will generate negative charge at ortho positions. These two double bonds as it is, C double bond O, oxygen only one lone pair, positive charge on oxygen and OH bond. OH bond is going to be present. And now what is going to happen? HCHO we have, HC double bond OH. We are treating this with H plus ion. Although it is more electrophilic, we can also increase the electrophilicity. Lone pair of electrons and oxygen, they can attack the H plus to form what? HC, oxygen only one lone pair and a positive charge and one new OH bond, and we have a double bond. This carbon is more electrophilic, that will be attacked by the negative charge at the para position. HC double bond O, oxygen only one lone pair, positive charge OH bond. Now negatively charged carbon from the ortho position, that will attack this particular carbon, electrophilic carbon, and C double bond O, electron density moves away. You will generate what? You will generate the negative charge is going to be connected to carbon COH, CH2, and we have C double bond O, OH, and this hydrogen is now going to be picked up, and loss of H plus is going to happen. CH electron density comes into, and again you get phenol. So loss of H plus will occur. Again you will be generating the respective phenol, and CH2OH substitute the CH2OH is going to be substituted at the ortho position. So that means if you take phenol and treat with the HCHO, that is formaldehyde, you will be getting CH2OH placed at ortho position. But as I have told you, along with ortho, para position is also electron rich. So both ortho and para can be substituted. Both the ortho and para, that means tri-substitution can also occur. So these are the mixture of products, and from these, if orthohydroxymethylphenol will be reacting, will be polymerization, under that category, you will be getting a linear polymer like this CH2OH. In the CH2OH, the connection is going to be lost. The CH2 groups are going to be connected with other molecules. Like if this OH bond is cleaved, that is the CO bond is cleaved, this carbon gets a partial positive charge that will act as the electrophile and gets attacked by the another molecule of phenol, thereby generating a CH2, C6H3OH CH2, C6H3OH CH2, C6H3OH CH2. This is repeated, which is nothing but your novolac. The linear polymer of orthohydroxymethylphenol, that is called as your novolac, and it is used in the paints mostly. And now if you look carefully, this novolac I can repeat in this direction also. I can repeat in this fashion also, I can repeat in this fashion also. If I repeat at the para positions also, or if I introduce the cross links at the para positions, then that solid whatever is going to be obtained, that is said to be bakelite. It is an infusible solid that is used to make the comms, electrical switches and all, and a cross linking polymer. Okay, novolac is a linear polymer. This is used in paints. From the novolac, the cross linking of novolac will be generating bakelite. Bakelite is this one. Like we have seen, this is novolac. Yes or no? This unit is novolac. That novolac is now cross-linked at the para positions also. CH2, again we have same linkages. Again other molecules are going to be present. That will be a polymer. That will be a cross-linked polymer, which will be having a lot of covalent bonds linked between many polymeric chains, and that is now called as bakelite. Is that clear? So novolac and bakelite, they are obtained by the condensation polymerization of phenol and formaldehyde polymers. Phenol react with formaldehyde to form orthohydroxymethylphenol. This orthohydroxymethylphenol will be polymerized to generate novolac, which is a linear polymer. Cross-linking of the Novolac, that is interlinking of many linear polymers using cross-links will be generating the bakelite, will be generating the respective bakelite. Is that clear?
Yes.
Yes.
Yes, right? Very good. Melamine formaldehyde polymer. Melamine, what is melamine? You have to remember the structure. Like you just remember benzene. 3 alternate carbon atoms you replace with nitrogens, and the remaining 3 carbon atoms you place NH2 groups. Okay, just draw the benzene. 3 alternate carbons you replace them with nitrogen atoms. The remaining 3 alternate carbons we have, right? There you substitute the NH2 groups. That is nothing but your melamine. In melamine, whenever treated with HCHO, what happens is, again same, what type of reaction you can expect? Lone pair of electrons and nitrogen, it can act as a base as well as a nucleophile. Here it is going to act as a nucleophile because it has an electrophilic carbon. We have Hc double bond H. Lone pair of electrons and nitrogen, they will attack the carbon. C double bond of pi electron and moves away. Ultimately, the NH bond is going to be cleaved here. You will generate a NH bond is cleaved, this NH, and next this structure is going to be same. NH, again NH bond is cleaved. Here NH, that is going to be connected with CH2. This is repeated n times. Melamine plus formaldehyde. If you try to look at the linkages, you will have this type of polymeric unit repeated. This is the polymeric unit. That means this unit is going to be repeated many times. This polymeric unit is going to be actually repeated many times, and this was the melamine polymer. Okay, and it is also a cross-linked polymer because it has cross linkages, and cross-linked polymers will be having a strength, a great tensile strength. They are strong. Okay, it is also a cross-linked polymer, and it is used for the manufacture of unbreakable crockery. And the intermediates present in between this is the NH2 is reacting with HCHO, forming NHCH2H, and this is going to be further repeated again, involving the cleavage of NH bond here, and CO bond here. CO bond, NH bond are going to be cleaved, which will be obtaining to the repetition part. So this is nothing but your melamine polymer or polymeric unit, and this was the intermediate which will form. That means when two molecules react, melamine and formaldehyde, whenever they react, they form this, and this upon polymerization generate this. Okay, so we have seen phenol formaldehyde, melamine formaldehyde, and we can also expect the next type of polymer, that is a urea formaldehyde, that is also called as resin. Urea formaldehyde means they are also used in the unbreakable cups and all. And urea means what? Urea means we have NH2 C double bond NH2 treated with the HC double bond H. It will form what, students? Here NH bond is going to be cleaved. Here NH bond is going to be cleaved. And here CH2H will be formed. So you'll get what? NH is going to be involved in the linkage. C double bond NH. And you have CH2H formed. Once the CH2H is going to be formed, the CO bond is actually cleaved in this scenario. Okay. In the alcohols, whatever the CH2H is group is forming, in the phenol formaldehyde or melamine formaldehyde or urea formaldehyde, the respective HCHO is converted to CH2H, right? From the CH2H, the CO bond is cleaved. You have NHC double bond NHCH2, and it is repeated n times. This is nothing but your respective resin or urea formaldehyde polymer, which is also called as resin. And it is used for making unbreakable cups and laminated sheets. Is everything clear so far, students?
Yes. Yes.
Yes, right. Very good. Try to solve these examples. Of the following, which one is classified as polyester polymer? Terylene. Terylene is obtained terylene ethylene glycol, and terephthalic acid. Which of the following is not a condensation polymer?
Neoprene.
Neoprene. Neoprene is a rubber, right? Synthetic rubber, it's not a condensation polymer. Which one of the following sets form the biodegradable polymer? Biodegradable polymers means two sets we have. PHBV, poly beta hydroxybutyrate, co beta hydroxyvalerate, and nylon to nylon 6. So nylon to nylon 6, if you look at glycine and aminocaproic acid, so which is nothing but your option 4. Biodegradable polymer which can be produced from glycine and aminocaproic acid. Nylon to nylon 6. Right, very good. The biodegradable polymer is nylon to nylon 6. Poly beta hydroxy butyrate co beta hydroxy valerate PHBV is a copolymer of beta hydroxy butyric acid. Yes or no? CH3 CHOH CH2COH 1 2 3 3 hydroxybutanoic acid CH3 CH2 CHOH CH2 CH3 1 2 3 IUPAC name they're asking. So 3 hydroxybutanoic acid and 3 hydroxypentanoic acid, that is the right name. 3 hydroxybutanoic acid and 3 hydroxypentanoic acid, that will be the respective correct answer. Right, students, these are the different condensation polymers and addition polymers. And after that, you have to understand the classification based on molecular forces. The polymeric chains, like there are different classifications we have seen based on the source, like natural polymers, synthetic polymers, semi-synthetic polymers, based on the type of polymerization, addition polymerization, condensation polymerization, based on the structure also, linear polymers, branched polymers, cross-linked polymers. And lastly, classification based on molecular forces. Classification based on molecular forces. Like first classification is elastomers, thermoplastic, thermosetting. Yes or no? If you look at elastomers are like rubber-like polymers. The polymeric chains are held together by weakest intermolecular forces. We have elastomers, thermoplastic, thermosetting, as well as fibers. So these are the 4 different types of polymers based on the molecular forces present. So first one is elastomers, right? The rubber-like polymers. The polymeric chains are held together by weakest intermolecular forces, because rubber will be having the weakest intermolecular forces. Examples: bunion, neoprene. Fibers, if you take the thread forming solids which possess high tensile strength and strong intermolecular forces like hydrogen bonding. Thread forming solids, they form a thread like polymeric chains. Thread forming solids which possess high tensile strength and strong intermolecular forces like hydrogen bonding, they are called as fibers. Example, if you look at the category, polyamides, nylon 6, nylon 6,6, polyesters, terylene. So the fibers, these are some. The examples of fibers are polyamides as well as polyesters. The fibers will be having the strongest intermolecular force of attraction like hydrogen bonding, and the elastomers will be having the weakest intermolecular force of attraction. After fibers, we will be having thermoplastic. Thermo means temperature, plastic means they become soft. Like if you look at these linear or slightly branched long chain molecules capable of repeatedly softening on heating. If you try to heat it, it becomes soft, and hardening on cooling. If you try to heat that, it becomes soft, and whenever it is cooled, it becomes soft, it becomes hard. So that type of polymer is said to be thermoplastic polymer. Intermolecular force of attraction, they are going to be intermediate between elastomers and fibers, because elastomers weakest intermolecular forces, fibers the strongest intermolecular forces like hydrogen bonding. In between these two, you will be having the thermoplastic polymer. Example, you can take polythene, polystyrene, polyvinyls. All these will be coming under this category. All these will be coming under this category of polymers. And then last category, what you are going to have is thermosetting polymers. The strongest, the very strongest thermosetting polymers are, these polymers are cross-linked. Because of the cross-linked, they will be having the strongest intermolecular forces and they are not going to be used again. So bakelite, urea, formaldehyde, okay, these cannot be reused. So these are nothing but your thermosetting. So thermosetting, because of the cross links, it will be having the extremely high intermolecular forces. After thermosetting polymers, you will have fibers. After fibers, you will have thermoplastic. After thermoplastic, you will have elastomers. That is the order of intermolecular forces in these different categories of polymers. Is that clear or not?
Yes.
Yes or no? So the order of intermolecular forces, thermosetting will be having the greatest intermolecular force of attraction. After that, you have fibers. After fibers, you will be having the thermoplastic polymers. After thermoplastic polymers, you will be having the respective elastomers. So these are nothing but the order of intermolecular forces. Try to solve this example. Which of the following is a thermosetting polymer? Thermosetting. Thermosetting means bakelite, urea formaldehyde, melamine formaldehyde. Those all comes under category.
Fourth option.
Fourth option, right? Because there's a linear polymer Novolac has been given.
No.
Repetition of that will be generating bakelite. Which of the following is a thermosetting? Thermosetting means bakelite.
Bakelite.
Yes, very good. Which of the following statement is false? The repeated unit in natural rubber is isoprene. Both starch and cellulose are polymers of glucose. Artificial silk is derived from cellulose. Nylon 6,6 is an example of elastomer.
Fourth option.
Fourth option.
Nylon 6,6 is not an example of elastomer. What is an example of elastomer? Butane, butane, they are all the examples. Very good. The polymer containing strong intermolecular forces, example hydrogen bonding is
Nylon 6.
6.
like fibers will be having the strongest intermolecular force of attraction. So nylon 6, polyesters and polyamides, they comes under this category. Okay, so this is all about your respective polymer students. And one more point which you need to understand is, in addition polymerization reactions, okay, in the addition polymerization reaction, like we have LDP, HDP, right? In addition polymerization, LDP means low density polythene. LDP means what? Low density polythene. This low density polythene is actually prepared whenever you heat like LDP, HDP, they are polythenes. Polythene means addition polymerization reaction, they are going to happen. So when you try to prepare, it is a polymer of ethene obtained by treating ethene with the peroxides at the pressure of, like ethene, you have to take ethene in the presence of peroxides and pressure of 1000 to 2000 atmosphere and temperature of 1000 to 2000 atmosphere and temperature of 350 to 350 to 570 Kelvin, and you will be generating respective LDP. And of course, peroxide should be there so that it will be having a chain initiator. It will be acting as a chain initiator. But HDP is high density polythene. High density polythene, and it is obtained by the polymerization of ethene at a pressure of 6 to 7 atmosphere and temperature of same ethene at a pressure of 6 to 7 atmosphere and a temperature of 330 Kelvin, around 333 to 343 Kelvin. And here you are going to have a catalyst like Ziegler-Natta catalyst. Anyone know Ziegler-Natta catalyst? Titanium tetrachloride plus triethyl aluminum. So this is nothing but your Ziegler-Natta catalyst. In the presence of Ziegler-Natta catalyst, ethene under this set of conditions and hydrocarbon solvent and hydrocarbon solvent will form HDP, high density polythene. High density polythene means branching is present or not present. High density polythene, high density, no branching, closely packed.
No.
Okay. Low density polythene means branching is present. Branching exists. Okay. These are respective addition polymerization reactions and the conditions which you have to remember as well. Fine. Thank you all. We have completed this polymers. Let us start with chemistry in everyday life. Just a second. Chemistry in everyday life. There you will be having, like if you look around ourselves, chemistry in everyday life means we are now studying about the chemistry of the species which you are interacting with in our day-to-day lives. So what are different types of chemicals which we interact in our day-to-day lives? Like we are highly dependent upon chemicals. The first point what you need to understand is we are so much depending upon chemicals, like it may be drugs, or it may be food materials, or it may be cleansing agents, everything. Okay, whatever the cleansing action we are going to depend on, like in our day we can't live without chemicals. That much how we are actually dependent, but we don't know that we are actually depending upon chemicals. So chemistry in everyday life, like if you think of food materials like pickles, sugar-free oils, yes or no, and a lot of other different other substances, cleansing agents like soaps, detergents, synthetic detergents, drugs and medicines, different types of medicines you are going to have. All these are chemicals. And we are highly depending upon these chemicals everyday life, these chemicals in our everyday life. Similarly, that we don't even remember or recognize that our dependence on chemicals is much vast and huge. And the polymers, so whatever we have discussed so far, they are all chemicals, and we itself are made of some beautiful biological chemical reactions. Who are we? We are made of some chemical reactions only. Yes or no? So chemistry is everywhere. So by now you have learned the basic principles of chemistry and also realized that it influences every sphere of human life. The principles of chemistry have been used for the benefit of mankind. So we are we are studying all this polymerization reaction, organic chemistry reaction for what? For developing, for the usage of us. Yes or no? We are preparing a lot of drugs. Why? Because to cure us. We are preparing all these polymers. Why? So that our day-to-day activity becomes easy. Yes or no? So for our usage only, we are preparing all this. The think of cleanliness. If you think of cleanliness, the materials like soaps, detergents, household bleaches, toothpaste, etc., that will come to your mind. Look toward the beautiful clothes. Immediately, chemicals of synthetic fibers used for the making of clothes and giving colors, they will be coming to your mind. Of course, sickness and diseases remind us of medicines. Again, chemicals. Chemistry has influenced our life so much that we don't even realize that we come across chemicals at every moment. That we ourselves are beautiful chemical creations, and all our activities are controlled by chemicals. Okay, chemistry has a great impact in everybody's life because we all are doing, or we all are using the chemicals at in every moment of our lives. So to understand the chemistry of the species which you are going to use in our daily lives, this chapter will be doing some effort in making us realize that how we are going to be using the chemicals in our day-to-day lives, and what was the chemistry behind those chemicals which you are using. And we again focus mainly on three things only, that is cleanliness, drugs and medicines, and respective food substances. Okay, food substances, cleanliness, soaps, detergents, and drugs and medicines. These are the three categories which we are looking at mainly. There are many other things like clothes we can do shopping and all. We can do, like everywhere we have chemicals. Yes or no? So, but our main focus will be on these food substances, cleanliness, and drugs and medicines in our chapter chemistry in everyday life. So first thing or first category is we have to understand about medicines. So chemicals in medicines. So first category is drugs. What are drugs? Drugs are chemicals of low molecular masses. Drugs are chemicals of low molecular masses. They interact with the macromolecular targets like proteins, lipids, and carbohydrates, nucleic acids, and produce a biological response. Drugs, they are going to be interacting with a macromolecule which was present inside a body, and they produce some response. Like you are suffering from some pain. I have suffering from some leg pain. I have taken a paracetamol. And what is the role of this drug? The drug has to realize where the pain is first. Yes or no? Drug has to work on that particular part where the effect is already there. That means drug has to identify the target. Drug has to interact with the target. That is called as drug target interaction. They interact. They means drugs. Drugs interact with macromolecule targets. Macromolecular targets, they may be enzymes, they may be receptors, they may be lipids, carbohydrate, different types of macromolecules are there. But again, in our chemistry, we limit ourselves only to two interactions. Drug target interaction, where the targets are considered as your respective enzymes as well as receptors. Not all the carbohydrates and all, because that will be again a bigger perspective, which is not in your syllabus. So drug, they have to identify the target and it has to go and interact with the target. After it interacts with the target, it should produce some response or biological reaction has to be happening and it should produce some effect. Because of that, our pain or our disease has to be cured. That is the logic. Medicines. When the biological response is therapeutic and useful, these chemicals are called medicines. Whatever the drug we are taking, no, if that drug has a biological response which was curable, which was therapeutic, then only we call that particular drug as medicine. Not every drug is called as a medicine. Only when the drug has some therapeutic action, then only it is called as a medicine. They use in diagnosis, prevention, and treatment of diseases. So we know medicines are going to be used in the diagnosis, treatment, and also prevention of diseases. Chemotherapy. Use of chemicals or drugs for therapeutic effect is called chemotherapy. Most of the drugs used as medicines are potential poisons if taken in doses higher than those recommended. That means since a paracetamol is a drug or a medicine which can be curing some kind of disease, I can't take some 10 tablets of paracetamol. Only in the predicted or recommended doses we have to take the particular medicine, because they are all potential poisons whenever you have been taken in excess. That is why, and that depends upon, that dose depends upon the age group as well. Like if a child goes to the doctor, he will be having a different dose. If an adult goes, he will be having a different dose. Like that, it varies, depend upon the body conditions and all. Classification of drugs. If you try to classify the drugs on the basis of pharmacological effect, that means this is useful for doctors because it provides them the whole range of drugs available for treatment based on pharmacological effect. On this basis, how we can classify the drugs? Example, analgesics. All of them will be having pain-killing effect. If we have analgesic, if we categorize all the drugs in the analgesics part, that means for the analgesics you can be using all this set of drugs, and based on the conditions of the patient, we will be choosing the right drug. Okay, so analgesics, antiseptics, anti-fertility drugs. So like that, if you classify all the drugs, pain-killing effect, analgesics, antiseptics kill all, arrest the growth of microorganism, anti-fertility, they are birth control pills. So based on the every category, if we just classify all the drugs, then it will be useful for a doctor to actually suggest a particular drug to medicine, particular drugs to the respective patients. So this is useful for the doctors, and that is why, and the name itself is pharmacological effect. Okay, based on the respective classification, analgesics, what are drugs available, antiseptics, anti-fertility, like that. Then comes the classification on the basis of drug action. It is based on the action of drug on a particular biochemical process. So on a particular biochemical process, how the drug is going to be acting. Like if you take histamine, Histamine is a species which is causing inflammation in the body. In the body, histamine is actually causing inflammation. It contracts the smooth muscles in the bronchi and gut also. So this histamine is causing inflammation, allergy and all. So to cure the disease caused by histamine, we'll be taking what? Antihistamine. That means it is based on the drug action, like what type of drug we have taken and it is doing what action, or what is the action of that particular drug. If you take an antihistamine, it will not allow the histamine to cause the inflammation. So that is why, based on the action of that particular drug, the naming has been done. Histamine causes inflammation in the body. If you take an antihistamine, it will inhibit the action of histamine. That means you will be having a normal body. So based on the drug action also, classification of drugs has been done. Based on the pharmacological effect also, classification of drugs has been done. And then comes the category on the basis of chemical structure. What is a drug, students? Like if I say paracetamol is having this particular action, what do you mean by that? What do you mean by that a particular drug has this action? That means a chemical reactivity or not? Chemical reaction is going to happen. The interaction of drug with the target is going to happen. If you think of the scenario, like a particular drug has a particular structure, and if you try to modify that particular structure with some small changes, that will also be having same activity. Like what is the activity of a drug? Why a particular drug has a particular action? Because it depends upon all the chemical reactions present in the functional groups on that particular drug molecule. Yes or no? If a particular drug I have taken, in that particular drug we have this set of functional groups, and the reactivity of those functional groups only you have to think of. Those functional groups, how are they reacting? In the process of reacting, what is the biological effect producing? That is what is actually helping us. Yes or no? So on the base of chemical structure, if the chemical structure is similar, then the drug action might be similar. Not exactly same, might be similar. Drugs which have common structure often have similar pharmacological activity, because structure is important. Similar structure, similar type of functional group, similar type of functional group, similar type of reactions, similar type of reaction, similar type of biological response. Okay. So drugs which have common structure or similar structure often have similar pharmacological effect, because the biological response is a reaction of, is a product of chemical reactions which are actually happening because of the presence of different kinds of functional groups. For example, sulfonamides have common structure feature given below. Sulfonamides, if you take NH2, C6H4, S double bond O, S double bond O, NHR. If you change the alkyl group R, it will be different types of sulfonamide. Like this is a general structure of sulfonamide. If I try to change the alkyl group R, that will be generating a different group. But this is the basic unit of sulfonamide, which is actually the similar structure or repeated structure. So on the base of chemical structure also you can classify, on the base of drug action also you can classify, on the base of pharmacological effect also you can classify, and then comes on the base of molecular targets. Drugs interact with biomolecules such as carbohydrates, lipids, enzymes and nucleic acids. Okay, different other drugs and nucleic acids. These are called as target molecules or drug targets. Most useful classification for medicinal chemists. Like you should know how a drug is interacting with a particular target. Okay, doctor is someone who will be suggesting the medicine. You use this particular medicine for this type of disease. But you have to generate the medicine first. Yes or no? Doctor will be knowing what kind of medicine you have to use for what type of treatment. He will be doing the surgery. He or she will be doing all the activities happening, but he is not someone who is actually preparing the drug. The drug preparation is done by R&D team. Okay. So research people, they are going to prepare the drug. When they are actually preparing the drug, they have to look at the type of interactions. The preparation of the drug is important. Yes or no? Like how a medicine has been generated. Like recently we have been through pandemic. Yes or no? How that particular drugs has been developed. Okay, the antivirus has been developed. That is very, very important. And it is not a single day job. It takes years to actually synthesize. Now let us look at the drug target interaction. Drug is going to interact with the target molecule. although we have different types of target molecules like listed above, carbohydrates, lipids, nucleic acid and all, we'll look at only two types of targets: drug target interaction, where the target molecule is actually enzyme, and drug target interaction, where the target molecule is actually respective receptors. Okay, these are the two target molecules which you are looking at. So let us now look at the drug target interaction, where the target molecule is an enzyme. So if a particular drug is actually like a drug target interaction, where enzymes as drug targets, if you talk about, like imagine the scenario, if I want to target a particular person, what I should know first? Okay, if I want to target a particular person, I should know how he behaves. I should know what was his activity. If I want to target a particular person, I should know what was his activity, day-to-day activity, how is his what he is doing all the day, at what time he will be at what position. Like that, I should know some information regarding his activity or not. The same way, similar way, if a particular drug has to interact with a particular target molecule, first point you should know is how that particular target molecule behaves. If you don't know the behavior of the target molecule, how can this drug interact? That is not going to happen. You have to first study the interaction, or you have to first study the behavior of that particular target molecule. Based on the behavior of the target molecule, you have to prepare a drug such that it will go and interact. That is the way. Okay. The simplest example which you can think of is, you should know the activity of the target molecule, then only you can prepare a drug such that that activity can be controlled. So macromolecules of biological response. Macromolecules of biological origin perform various functions in the body, like carbohydrates, proteins, nucleic acids, lipids. They have various functions. For example, proteins which perform the role of biological catalysts in the body, they are said to be enzymes. What are enzymes, students? Enzymes are proteins which produce or which catalyze biological reaction. Proteins, enzymes are proteins which catalyze biological reactions. Carrier proteins carry polar molecules across the cell membrane. Nucleic acids, they will be having all the coded genetic information for the cell. Lipids and carbohydrates, they are the structural parts of cell membrane. So every biomolecule will be having a specific activity. Now let us look at the, as I have told you, in our syllabus only we have the interaction of drug target interaction, like enzymes as drug targets as well as receptors as drug targets. First, you should know how the enzymes are going to work. How the enzymes are going to be working? Yesterday I have told you enzyme has two major functions. Enzymes has two major functions. What are those enzymes' two major functions?
Enzyme substrate complex formation.
Enzymes will be having actually two major functions. The first function is it has to hold the substrate for the chemical reaction. The second function is it has to provide the functional groups so that the substrate will be reacting with the functional groups and undergo the reaction. Yes or no? Two functions. Enzymes will have two functions. First function is enzyme should be having two functions. What is the first function? To hold the substrate. Yesterday we have drawn the figures, right? The substrate will be going and binding to the respective active site. The second function is to provide functional groups. Okay, to provide functional groups. Now let us say this is our enzyme. It has to be providing active site, like the site which is responsible to hold the substrate. It is said to be active site. This is a substrate, this is enzyme. The substrate is going and binding, and this particular active site means what? The enzyme is holding the substrate. The enzyme is holding the substrate means it doesn't mean there are no geometrical figures, as I have told you in the last class also. The enzyme will be developing new intermolecular force of attraction with the substrate that binding can happen. the enzyme will develop the new intermolecular force of attraction with the substrate so that the binding can happen. After the binding occurs, we form the complex, and from this complex, the enzyme substrate complex, this is enzyme substrate complex. This complex will be giving rise to enzyme and products are formed. So this enzyme has to provide the functional groups. So the substrate which has been present, no, that will also react with the substrate to form the product, and enzyme is going to be released back. Like that, the reactions are going to happen. Now, can I say, let us say there was a lot of enzyme inside of body. Like in my body, only some specific quantity of enzyme should be there, but somehow more enzyme is there. Somehow the reaction or the product formation is more. That means I have to stop this product formation. If product is formed in excess, it will be affecting my body. If I want to stop the product formation, what I have to do? What I can do? Can I stop the interaction of substrate with enzyme? If I stop the interaction of substrate with enzyme, obviously you will not form a complex. Obviously, product is not going to be formed. Yes or no?
Yes.
Yes.
The
Sir.
point
Yes.
is the enzymes has two functions: to hold the substrate and to provide functional groups for the substrate to react. But if I do the reaction in such a way, enzyme and substrate, they are reacting with each other to form a complex, enzyme substrate complex, that will be converting into products and enzyme. If the product concentration is more, it might be dangerous. In that scenario, what I can do? I can stop the substrate to go and bind to this particular enzyme. Then what kind of drug I'll take is, then I can actually stop this interaction by two ways. What are two ways? I can take a drug which is acting as a competitor for the substrate. Like now, there is a first position. Okay, you all are in running race. In the running race, there are two persons who are in the race. And what is your chance of winning the race? 1 by 2. If there are 10
50%.
persons in the running race, what is your chance of winning the race? 1 by
10%.
10.
By 10.
So whenever the number of persons are more, your chance of winning the race will be less. That is a general logic. It depends upon other activities like how much you have performed and all. Same way, here substrate is there. We will be taking a drug in such a way which is acting actually act a competitor for this substrate. So this drug also has a tendency now to go and bind to this particular active site. Earlier only substrate is going and binding to the active site. Now drug will also go and bind to the active site. So can I say effective interaction or effective enzyme substrate complex formation is decreased or increased?
Increased.
Decreased, right?
Decrease.
Because earlier only substrate is going and binding. Now I have taken a drug which is also going and interacting with the respective enzyme. So obviously substrate cannot go and interact greatly as earlier. So in that category, you will be having the less formation of the enzyme substrate complex, obviously less product formation. So the drug which I can take is a competitive inhibitor now. It is actually acting as a competitor for the substrate. I can also take a drug. Let us say this is the enzyme. I can also take the drug. I can also take the drug in such a way such that this drug will go and bind to a different active site, which is said to be allosteric site. This drug can bind to the same active site where enzyme is binding, so that it is acting as a competitor to the substrate. This drug will go and bind to the same active site where the substrate is binding, so that it acts as a competitor for substrate, so that less will be product formation. Or this drug will go and bind to a different site. Because of the binding of drug with this different site, the structure of this previous active site that has been changed. First thing is I'm taking a drug as a competitor. Second thing is the drug is actually binding at a different site, not at the same site where the substrate is binding. But because of this drug binding at a different site, the structure of active site that has been changed. Since the structure of active site has been changed, lesser substrate will now go and bind or not?
Sir.
Obviously, less is a product formation. So this is the two ways in which the drug can actually interact with the target. First, you should know the enzymatic activity. Enzymes will actually hold the substrate molecules and provide the functional groups. So the drugs can be acting as a competitive inhibitors, or they can also be binding at the allosteric sites, so that the structure of the original active site that will be changed. Very simple. So let us look at the same. Drug target interaction. Enzymes as drug targets and receptors as drug targets. Only two drug target interactions are there in your syllabus. First, let us look at enzymes as drug targets. Catalytic action of enzymes and drug enzyme interaction. Similarly, body's communication process, how is going to happen? First, you have to understand with respect to receptors, and drug receptor interaction also has to be studied. First, we are looking at this enzymes as drug targets. As I have told you, how the catalytic action of enzyme is going to be happening. Enzyme perform two major functions. What are these? First, to hold the substrate for a chemical reaction. Active sites of enzyme hold the substrate molecule in a suitable position, so it can be attacked by reagent effectively. What are the active sites? Active sites are not some geometrical figures. They are the intermolecular attractions developed between an enzyme and substrate. What type of attractions they can be? Like hydrogen bonding, ionic bonding, van der Waals interaction, or dipole-dipole forces. Substrate bind to the active site of enzyme through a variety of interactions such as ionic bonding, hydrogen bonding, van der Waals interaction, or dipole-dipole interaction. This is the first role of enzyme. Second role, the second function of enzyme is to provide functional groups that will attack the substrate and carry out the reaction. Because not holding the substrate will not do the reaction. The substrate should be reacting with the specific functional groups. So the second function of enzyme is to provide functional groups that will attack the substrate and carry out the chemical reaction. Like you look at the enzyme will be having a respective active site. That substrate will go and bind to the active site of the enzyme, and that will lead to the formation of complex. Is that clear, students? Action of enzyme, is that clear or not?
Yes, sir.
The same
Yes, sir.
thing, whatever I have
Yes.
explained, again we are seeing the slides. Drug enzyme interaction. Drugs can block the binding of the enzyme and prevent the binding of substrate, or can inhibit the catalytic activity of the enzyme. Such drugs are called enzyme inhibitors. What are these? Drugs can actually go and bind to the active site of the enzyme before the substrate can go and bind. That means it is acting as a competitive inhibitor. Drugs inhibit the attachment of substrate on active site in the enzyme in two different ways. What is the first way? Competitive inhibitor. Drugs compete with the natural substrate for their attachment on the active site of enzyme. Drugs, they compete with the natural substrate for their attachment at the active site. Because of that, the substrate binding to that particular enzyme will be decreased. Thereby, enzymatic activity will be decreased. Second point, what I have told you?
Allosteric.
Allosteric sites, yes or no? Drugs will be acting as a competitive inhibitors like this. Instead of substrate going and binding at the active site, drug can also bind. Second point is, some drugs do not bind to the enzyme's active site. These bind to a different site of enzyme which is called as allosteric sites. Because of the drug binding at the allosteric sites, the structure of active site that will be changed. This binding of inhibitor at allosteric site changes the shape of the active site in such a way such that substrate cannot recognize it. Substrate cannot recognize the active site now because the interaction has been changed. Earlier substrate has in dipole-dipole. Now because of a drug going and binding at the active site, the dipole-dipole interactions with the enzyme are not there. So the substrate cannot go and bind there. Yes or no? So this is your allosteric site, the inhibitor. So inhibitor occupying the allosteric site, that means drug occupying the allosteric site. Because of this, the shape of the active site has been changed or not? Shape changed means you have to understand the intermolecular force of attractions are different now. So the drug and enzyme. So the enzyme cannot hold the substrate now, thereby decreasing the enzymatic activity. Right, students, this was your drug target interaction, where the first target molecule is as enzymes. Enzymes are proteins which are acting as biological catalysts. The second type of interaction is receptors as drug targets. Is the enzymatic activity clear? Drug target interaction.
Yes.
Yes, sir.
Very good. Then comes the receptors as drug targets. What are receptors? What are receptors? Like message sending activity now. Okay, receptors, they are some proteins actually, which are actually responsible for body's communication process. Like we have cell membrane, right? Most of the receptors are present in cell membrane. Like if you have cell, if you just try to look at the bigger image of cell membrane, this is the outer surface of cell membrane. This is the inner surface of membrane. The outer surface and inner surface of cell membrane we have. And now receptors are actually present or embedded in the cell membranes, such that the active site, like similarly, same as your enzyme, the receptor is also going to have an active site. The active site of a receptor will be projected out. Okay. The active site of a receptor this is the active site of receptor. Receptors are actually embedded in cell membranes. The active site of the receptor will be projected out of the membrane. Okay. Receptors are proteins that are responsible for the body's communication process. Like how the communication happens? Like from the brain, whatever the neurons we have, they have to the message between two neurons in the brain and between neurons and to the muscles, that is communicated through some chemicals or not. Like if I touch a hot object, immediately I'll remove my hand. I can't hold, like if I intentionally want to touch the hot object, there's a different scenario. If I intentionally want to touch the hot object and keep my hand like that, that was a different scenario. But if I touch a hot object, I instantly remove my hand. That is happening. Who is sending that message? Brain. So the message between two neurons in the brain, between the neuron and to the muscle, that is actually transferred, that is actually given using some chemicals known as chemical messengers. So there are some actually certain chemicals known as chemical messengers which are responsible for the transfer of message. They are actually giving the message. So same thing, if I touch a particular hot object, immediately my brain has to send a message. It has to send a chemical messenger to that particular organ, to that particular muscle, so that you remove the hand from that particular position. You remove the hand from that particular position. But so I touch a hot object, immediately my brain has sent the message. So chemical messengers started, immediately their motion is very fast. They reach the respective cells. So whatever the chemical messenger you have, that chemical messenger, okay, that chemical messenger will actually reach the respective cell membrane, and that chemical messenger will bind to the active site of receptor. Binding to the active site of receptor, once the chemical messenger binds to the active site of messenger, that will actually, the message will actually enter the cell. Once the message enters the cell will behave as per the message given. The cell will behave as per the message given. Immediately we will be taking out hand from that particular body. Yes or no? Is that clear?
Yes, sir.
Yes, sir.
So what is actually happening, students? If I touch a hot object, my brain will be sending a message through chemical messengers. The chemical messenger read that particular muscle. At that particular muscle, what is going to happen is the chemical messengers will bind to the active site of receptor. Once the chemical messenger bind to the active site of receptor, the message will enter into the cell. Once the message enters the cell will behave as per the instructions given. That means the chemical messengers will give the message to the cell without entering the cell. They do not enter the cell. They are just binding at the active site of receptor. Okay, without entering the cell, the chemical messengers are giving message to the respective cells. So receptors, and now we can also have two things. This is how the message activity is actually happening. This is how the process of message or communication process inside the body is happening. But now by somehow the communication is lacking. Whenever the communication is lacking, like even though you touch the hot object, I am not removing my hand easily because the brain is not sending the chemical fastly. Whenever I touch the hot object, the brain is not, like whenever there is a lack of chemical messenger, there can be a chance that I'll be lacking some chemical messenger. So under that condition, what happens? Even though I touch a hot object, my hand, I won't remove a hand because I message has not went to that particular body. I don't know. So I am not like whenever there's a lack of chemical messenger, what type of drug I am going to take is I am going to take a drug which will mimic the chemical messenger. Mimic means which will be similar to that of chemical messenger. So now what happens, instead of original chemical messenger or natural messenger, this is a drug which is actually acting as a chemical messenger that will go and bind to that particular receptor, thereby giving the message. Thereby I'll remove the hand. Whenever there is a lack in message, I have to take a drug which will be behaving as a chemical messenger. Whenever I want to stop the message, now under some condition I'll be taking the anesthesia. Like if I go to the tooth doctor, like dental care, I have a pain in the tooth, so I don't want this part of the body to be having pain, so that he'll be performing whatever the action he want to do, the root canal or everything, whatever he want to do. So in that whole time, I should not be feeling the pain. So what he'll do? So similar to that, not exactly same. Like he will be making or giving the anesthesia such that you won't feel any pain. Yes or no? That means in that particular body, the message is not actually transferred. You are not having the pain. The message is actually not transferred to that particular cell. That means the chemical messengers now they are not going to be going and binding to the receptors. Rather, there are some drugs which are stopping these chemical messengers to go and bind. Understood this point or not? If there's a lack in chemical messenger, I can take a drug which will mimic the chemical messenger. It will go and bind. It will give the message. If I want to stop the message, I will take a drug which will be acting as a competitor to the chemical messenger. So the drug will go and block the active site of the receptor so that the message is not entering the cell. Like that, two types of scenario can be there. Is that clear?
Yes, sir.
And the
Yes.
names have been given, antagonists and agonists. What are antagonists? Antagonist means
Opposite
whenever
function.
the blocking of message has been required, like the drug has to go and block. Antagonists, whenever the message has to be blocked, you will take a drug such that it will go and bind to the receptor. The chemical messenger will not go and bind. Agonist means whenever there's a lack in the natural messenger, so you have to take the agonist. That means it will mimic the, or it will be having the similar property of that of your chemical messenger. So this is your receptor protein. This is the outer surface of the cell membrane, interior of the cell and inner surface of the cell membrane. This is some active site or binding site of the receptor. So chemical messengers, what are chemical messengers? Message between two neurons and that between neurons to muscles, that is communicated through certain chemicals known as chemical messengers. Chemical messengers are received at the binding site of receptor proteins. To accommodate a messenger, the shape of the receptor should change. Obviously, that should happen. The same points, whatever I have explained. This brings about the transfer of message into the cell. This chemical message, thus a chemical messenger gives message to the cell without entering the cell. The chemical messenger will be giving the message to the cell without entering the cell, just by binding to the binding site of the receptor protein. So you can have this type of scenario. This is the interior of the cell. This is the receptor protein. Okay, that is actually the active site of receptor. The chemical messenger is coming. Chemical messenger, whenever it comes and bind to the active site, the message enter the cell. That is how happening. The message enter the cell. That is the active site. Now drugs interacting, drug interaction on receptors. Two categories: antagonists. Antagonists will actually block the binding site, so the chemical messenger will not be binding there. Agonists, they mimic the chemical messenger, so they will bind. So antagonists, they are blocking. So antagonists are those drugs whenever the message has to be blocked, whenever blocking of message is required. Agonists are those drugs whenever more message, whenever there's a lack of a natural messenger, we'll be using agonists. Is the animation clear?
Yes, sir.
Yes, sir.
Yes.
Yes, right. Receptors as drug targets. Antagonists, when they are used, drugs that inhibit the receptors and inhibit its natural function. These are useful when message blocking of message is required. Agonists, agonist means drug that mimic the natural messenger by switching on the receptor. That means they are useful whenever there is a lack in the natural messenger, right? Just read this. I'll be back within a minute. All right, students, is everything clear?
Yes.
Yes, sir.
That's right. So antagonist means they are useful whenever the blocking of message is required. Agonist means they are useful whenever there's a lack of natural messenger. So this is how drug will be interacting with the target molecule, like enzymes as drug targets as well as receptors as drug targets, right? After looking at the drug target interaction, we will be studying about therapeutic action of different class of drugs. In that, first we have antacids, antihistamines, neurologically active drugs like tranquilizers as well as analgesics. Analgesics again, non-narcotic and narcotic, antimicrobials, antibiotics, and antiseptics and disinfectants come under this category. And finally, you will be having the anti-fertility drugs. And in the antibiotic, you have bactericidal as well as bacteriostatic. So these are the different classes of drugs which you will be studying in your 12th standard. So first, let us start with antacids. Antacids means what? So if you look at acidity, acidity is the major problem. Yes or no? Which is faced by most of the people. So overproduction of acid in the stomach. If more and more amount of acid is produced in the stomach, that will cause acidity and that will cause the irritation as well as pain. You have to control the acidity. If acid is formed in the stomach, I think I have explained about this antacids earlier also whenever we are discussing about pH, common and effect and all.
Yes,
Anyone
sir.
remember?
Yes, sir.
There we have already told you that like inside our stomach, whatever acid produced, that will be having a pH of 2, that is very strong acid. So that a strong acid concentration great means it will be causing irritation and pain. In the severe cases, ulcer is developed in stomach. Like if we are not taking a proper medication, ulcer can also be developed in the stomach. Okay, if you have an acid and if you have a base, if we have more acids, if you have more acids, then obviously you will be taking base so that acid and base can react, so that the acidity can be reduced. This was the first idea. The first idea what people got is, because of acidity, because of a strong acid, so if I can take a base so that acid and base can react, neutralization can occur. In that perspective, people thought, and they have started taking sodium hydrogen carbonate, NaHCO3, or hydroxides of magnesium and aluminum. So two types they have taken. Treatment of antacids, if you look carefully, first treatment is sodium hydrogen carbonate NaHCO3, which is a weak base, and a mixture of aluminum hydroxide or magnesium hydroxide. The goal is simple. The acid is present in the stomach greatly, so these bases will be reacting with the acid so that they can reduce the acidic nature. But what is the difficulty we are having whenever you take NaHCO3 is, NaHCO3 is actually soluble in our stomach. Since if it is habituated to take NaHCO3, since it is soluble in the stomach, what is going to happen? If you have taken more of NaHCO3, whatever the acid present in the stomach, that may be reacting with NaHCO3. And if you are taking unknowingly, if you take more amount of NaHCO3, the stomach becomes basic in nature, that is alkaline nature. If the stomach becomes alkaline nature, what happens is that will actually trigger the production of more acid or not, because according to Lee-Charles principle, more acid should be released into the body whenever the stomach is alkaline in nature, because the stomach has to be acidic. If you are making it alkaline, that will actually trigger the production of even more acid, which will be even dangerous. But if you take the mixture of aluminum hydroxide and magnesium hydroxide, they are basic, they will be reacting with the acid. But since they are not soluble, they will never increase the pH greater than 7. So they will not be making the stomach alkaline. So they are a better alternative when compared to NaHCO3. Excess usage of NaHCO3 makes stomach alkaline and trigger the production of even more acid. Whereas if you take a mixture of aluminum hydroxide and magnesium hydroxide, it was a better alternative because these are insoluble and hence do not the pH above neutrality. But if you look at both these treatments, that means NaHCO3 and mixture of ALOH second phase and MgOH second phase, like the whole idea is like there is acid in the stomach and we are taking base, that base can be reacting with the acid so that neutralization occurs. There is acid in the stomach, we are taking a base will be reacting with the acid so that neutralization will occur. But this idea is actually controlling the symptom. This treatment is only controlling the symptoms. Sorry. The taking of base is actually controlling the symptoms only, not the cause. What was the cause? Production of more acid. The acidity can be controlled if you control the production of acid. It's not like we have to control acidity, means it's not like the acid has to be produced so that we can take a base. We have to stop the production of more acid. It is not like we have to react the acid obtained. Understood the treatment? If we are taking a medicine which is actually reacting with the acid already present in the stomach, that is just controlling the symptoms, not the cause. The cause is production of more acid. If we take a medicine, that medicine has to control the production of more acids. So then comes the revolution of antacids. Actually, there was a chemical pepsin is released along with HCl. Okay, there was a chemical release pepsin along with HCl. There is a drug target interaction happening. So if you take an antacid, that antacid will go and bind to the receptors on the stomach wall instead of binding of a different substrate molecule, so that the acid is not going to be obtained in a greater quantity. How we can control the cause, how the antacids are going to work, we will discuss in detail in the next session. After that, we have antihistamines, antimicrobials and all. Fine. Thank you all everyone. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Yes.